Hello everyone. In this video, we're going to be solving an exponential equation. Now, I wrote this equation in a certain way. Obviously, this can be written in more than one way. But if you noticed that 4 and 25 are both perfect squares. So we're going to generalize here and, kind of like look at it from a more general perspective and see how we can handle these kinds of equations. Because I'm pretty sure you're going to see lots of these on YouTube. So what is so significant about 4 and 25 being perfect square? It's not only that, it's also the fact that if you square root them and multiply together, you get something interesting. So let's talk about it in more detail. We have 4 to the power x minus 25 to the power x equals 10 to the power x. So since 4 and 25 are both perfect squares, I can basically write this as 2 to the power x squared minus 5 to the power x squared. And notice that 10 to the power x can be written as 2 times 5 to the power x, which can be written as 2 to the x times 5 to the x by using properties of exponents. And what is that property called? When you have something like ab to the power x, you can write it as a to the x times b to the x, which you can call distributing the exponent. All right, so that's one of the properties that we used. Now let's see how we can handle these kinds of problems by using a really cool method. And guess what? It's called substitution. How does substitution work? You replace something with something else. And you can use letters. Most of the time we do use letters, right? So let's go ahead and replace 2 to the x with a and 5 to the x with b. So some people complain about purple not being visible on black background, so I'm going to try not to use that color. So hopefully this is good. If you can't see any of these colors, please let me know if they're not, like bright enough. So anyways, if a and b are those, this is also going to be a and b. So we get the following. A squared minus b squared equals ab. Great. So on the left hand side, we have a difference of two squares, which is factorable. On the right hand side, we have a product, which is factorable. So how do you put those together? Does that mean we're going to factor the left hand side like this and then set these equal to each other? So does that mean a plus b is a or b? No, not necessarily, because if you assume that one of these has to be 0. But that's not the case. We all know that 2 to the x or 5 to the x will never be 0 unless x approaches negative infinity. And that's a limit, not a numerical value. Great. So here's what we're going to do instead. Since we got this nice structure here, we're going to divide both sides by b squared. Let's do it. And you'll see why in a little bit. That works. When we divide both sides by b squared, of course, we can separate this. We can write this as a squared over b squared minus b squared over b squared, which is 1, by the way. And the right-hand side, b cancels out, and we end up with a over b. Do you see where this goes? Awesome. And guess what? We're going to use substitution again, because substitution is fun. So let's go ahead and call this t. If you want to call it r for ratio, that's fine too, but I'm going to call it t. So we get t squared minus 1 equals t. Awesome. What am I going to do with this? This is quadratic, no more substitution. You don't need to. Let's go ahead and put everything on the same side and solve this golden quadratic. Wait a minute. Did I say golden? Why? You'll see in a little bit. Let's go ahead and solve it. Negative b, 1, plus minus the square root of b squared, 1, minus 4ac, 1 plus 4 is 5. And yes, if you said golden ratio, you got it right. There are two possible values because this is quadratic with a positive discriminant. So it's going to have two real solutions, but one of them is not going to be good. Why? Let's find out. What is t? T is a over b. What is a and b, right? A is 2 to the x. So let's go ahead and kind of look at our findings. T is a over b. A is 2 to the x, and b is 5 to the x. So t is basically 2 over 5 to the power x. That's interesting, right? Well, it shouldn't be very interesting, but anyways, let's call it interesting. All right, so, but this tells us something. 2/5 to the power x cannot be negative. Did I say negative? Well, 1 minus root 5 over 2 is less than 0, so we're going to have to discard it, because something to the power x cannot be negative, especially when the base is positive. When the base is negative, what happens? Like if you have something like this, this is going to be super duper crazy. Think about it. It's just going to jump all over the place because you're going to have a lot of complex values. Now think about it. What is negative 2/5 to the power 1/2? It's the square root, but that's going to contain I, complex world, so on and so forth. Okay, so many issues. Now let's go with the only solution, because that's the only thing we have. So t is a over b, and that is equal to this. Remember that. So t is 1 plus root 5 over 2, and that is 2 over 5 to the power x. What am I going to do with this? Well, let's write it this way, because it kind of looks a little nicer. Equals 1 plus root 5 over 2. Why all that space? Because I'm going to natural log both sides. All right? I probably need a little bit space here too. So let's go ahead and move this guy over here. All right, cool. Now we're going to natural log both sides, and that's going to give us the following. X is going to move to the front. X times ln 2 over 5 is equal to ln 1 plus root 5 over 2. And why did I write it like that? Because I'm going to divide both sides by ln 2 over 5, and that's going to give me the x value. So it's just a ratio of 2 ln's, numerical values, so we can basically find x from here. Make sense? Yeah, hopefully it does. I mean, it should, right? Why not? But let's go ahead and look at the original problem one more time, because I told you this is going to allow you to generalize because of the way I gave you the problem. But, you know, sometimes it's not given like this. For example, this problem could have been given to you like 10 to the x plus 25 to the x equals 4 to the x. Would you be thinking the same thing? Yes, you should be. So always look for perfect squares and then try to associate them by using substitution, because substitution is awesome. All right, so let's see how we can also approach this problem a little differently without using substitution. It's going to turn out to be the same thing, but anyways, I just want to show you. Now, 25 to the power x is the largest base here, right? 25 is the largest base. So let's go ahead and divide everything by that. So I'm going to divide by this, 25 to the power x, 25 to the power x, and 25 to the power x. This is another way to approach it. The first one is going to become 4 over 25 to the x minus 1. And this is going to become 10 over 25 to the x. Now, as is, it doesn't look very interesting, but notice that 10 over 25 can be simplified. So if you divide by 5, you're going to get 2 over 5. Let's replace it with that. We get 4 over 25 to the x minus 1 equals 2 over 5 squared to the power x. What does that tell you? That tells you to use substitution. I think I messed up. It shouldn't have a square in it. The other one should have a square in it. So I could probably write it like this. Sorry about that. This is going to be 2 over 5 because we simplified it and we got 2 over 5. Yes, here we go. Now notice that 4 over 25 is 2 over 5 squared. So we get the same situation. You can call this A and proceed as follows. Make sense? So hopefully this helps you out with the type of problem that we're getting, and you can always, almost always, put it in this form, and remember to divide by a squared or b squared. If you divided both sides by a squared, it would still work, but it would just be a little different. Anyways, let's go ahead and take a look at the graph of these two functions and see where they intersect. Interesting curves, right? Like they're not always increasing or decreasing. I think one of them is always increasing, right? The orange one, 10 to the x, obviously, but the first one has a maximum at some point. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.